that's defined in a base class. Let's take a look at how this is done. We'll make a working copy of simpleinheritance.cpp from our Chapter 9 folder of the exercise files, and we'll paste that into our working project and open it up here. I'm going to maximize this and just scroll through it really slowly so that those who are typing along at home may follow along. And this is the same example we've been using throughout this chapter. It's got a base class called animal that gets inherited by 3 derived classes, dog, cat, and pig. And then these are instantiated to objects in main, and we call the speak method on the base class and the walk, pet, and feed methods on the derived class. So we'll go ahead and just compile and run this, and you can see how it works. And so down here in main, you see we call speak 3 times for each of them. Rover the dog says woof, Fluffy the cat says meow, Arnold the pig says oink, and then we walk the dog, pet the cat, and feed the pig. Let's say that we just want to change this speak method just for the cat. We can do that by overriding the speak method in the cat class. And that works like this. First, we create a speak function member in the cat. And you'll notice that Eclipse gave us this little purple triangle. And if I hover over that, it says shadows animal speak. And that's because up here in animal, there is a member function called speak on line 17. So now let's go ahead and define it. We have declared it. Now we'll define it. And there we have that same little purple triangle there. Shadows animals speak. And we'll just simply say cout per and endl. So now when we compile and run this, we really don't have to do anything else. When we compile and run this, you'll see that the cat is purring instead of saying Fluffy the cat says meow. And that's because this version of speak is being called instead of the animal version of speak. That was pretty easy. In fact, if we want to also call the base class method, we can simply say animal speak right there inside of cat speak, and we can compile and run that, and then we'll get both. You'll notice here, Fluffy the cat says meow and purr. Right? For right now, I'm just going to have the purr in there. Compile and run one more time so we can see that we have that. We have just the purr. And so that's doing exactly what we expected to do. Pretty easy, right? There is, however, one problem with this still. And in order to see that problem, let's create a generic pointer and see if we can access all of these methods from the generic pointer. So I'm going to go ahead and I'm going to delete all of these calls to speak that are off of the objects. And I'm going to create an array of animal pointers. I'm going to initialize that array to the addresses of these 3 classes. And I'm going to terminate it with a null pointer. I'm using the C++11 null pointer keyword here. You'll notice that my version of Eclipse is complaining about that, and it says symbol null pointer could not be resolved. But in actuality, when I compile and run this, because I'm using a version of GCC that understands C++11, it'll actually compile and run just fine. That's just a problem with this version of Eclipse. And if you have a later version of Eclipse, it may actually not be doing that anymore. So now I'm going to create a little for loop to loop through these pointers and call the speak method on them. And that's as simple as that. And so now, rather than calling d.speak, c.speak, and p.speak, we're actually generalizing this because it's code that gets run more than once. This is a very common thing to do. And so we have a generic pointer. It's an animal pointer. It's a pointer to the base class, which actually should work just fine for each of these derived classes. And we have that array of those pointers, and we're iterating through that array and calling speak on each one of those pointers. So let's go ahead and compile and run this. So you can see this appears to be working just fine, except that, oh, you'll notice it says Fluffy the cat says meow. It's not calling the derived class speak, it's calling the base class speak. So we are using an animal pointer here, so it appears to just be calling the animal method for all of these. and it's ignoring the derived method for cat. So there is a way to fix this, and the way to fix this is to declare speak as a virtual method. And so I'm going to use the virtual keyword here, and that's a qualifier, and that qualifies that speak method as being inheritable. And you'll notice when I add that virtual keyword, that virtual qualifier, you notice we get a little warning on each of our derived classes here, and it says, has virtual method speak but non-virtual destructor. So what this means is that whenever you declare a virtual method in a base class, you need to also declare a virtual destructor, and that looks like this. And that simply lets the destructor in each of the derived classes also overload the destructor in the base class. And this is really important because this makes sure that the destructor that's actually called matches the object that's being destroyed. In other words, if we're allowing certain methods to be overloaded in derived classes through a generic pointer, through a pointer to the base class, when that object is destroyed, if it's also destroyed through a pointer to the base class, this will make sure that the appropriate destructor is actually called. Even though Eclipse put up a warning there, it's not actually a hard class requirement, but 99 times out of 100, it's the right thing to do. So now we have our virtual speak and our virtual animal. And so if I simply compile this and run it, I'm going to save first and compile and run. Now we see that even though we're using this generic pointer, and this pointer has been declared as type animal, when we call it on a cat object, it calls the derived version of the overloaded class. You'll also notice that up here in this little green arrow, it now says overrides animal speak. If we didn't have the virtual in here, and I'm just going to go ahead and I'm going to remove the virtual there and save that, and we'll come down here and we'll see that the little arrow's a different color, and it says shadows animal speak. So that's just something that Eclipse is doing for us to show us the distinction. Shadow means that it's not virtual, and overrides means that it is virtual. So now the little arrows are green and they say overrides. So overloading methods in derived classes is a fundamental part of polymorphism, and this gives you a lot of power and flexibility in how you design your classes. By using the virtual qualifier, your overloaded methods can even